Hello, Pre-Algebra students. This is Chapter 6.2, Writing and Solving Proportions. A proportion is an equation that states that two ratios are equal. When we learned this in 6th grade math, we called these equivalent ratios. For example, 2/3 is equal to 8/12. And stated algebraically, A over B is equal to C over D as long as neither B nor D is equal to 0. Let's work out a couple of problems with this concept. One way that we can use what we know about equivalent ratios is if one of the numbers in a proportion is unknown. We can then solve the proportion to find the unknown number using what we know about equivalent ratios. So we can use mental math to figure out the value of x, looking at these two fractions that are set up as a proportion. So if 5/6 is equal to x over 18, all we need to do is figure out what factor we're multiplying by to create our equivalent ratio or to create our proportion. So what times 6 would equal 18? That would be 3, right? So we're going to take 5 times 3 to solve for x, which would be 15. So the missing quantity in our proportion here is 15. So 5/6 equals 15/18. Try these 4 problems on your own. In each you have a proportion with a missing variable. Use equivalent ratios to solve. Press pause while you work, and we'll move on to the next idea when you come back. In our first example, we learned to solve a proportion using mental math. Now we're going to solve a proportion using algebra. So first we'll write our original proportion, x over 12 equals 2 over 8. Now we're going to multiply each side by 12. Let me move this to give us a little more space. So we're going to multiply each side by 12 to isolate our variable x. So now we have 24 over 8. Now we simply solve by dividing. 24 divided by 8 equals 3. Therefore, the value of x must be 3. So now, to check our work, we're going to rewrite our proportion with our value of x inserted. Let's reduce these two fractions in our proportion to see if they can reduce to the same amount. 3/12 becomes 1/4, and 2/8 becomes 1/4. Therefore, our solution checks out. X is equal to 3. Here are 4 problems to try on your own. Use algebra to solve these rather than mental math. Show your work. Press pause while you work, and when you come back, we have one last concept to explore. Our last idea in Chapter 6.2 is learning to set up a proportion. So let me talk you through this entry from our textbook. There are different ways that you can set up a proportion. Let's look at this problem and then show 2 different ways you could write a chart to create a proportion. Yesterday you rode your bike 18 miles in 2.5 hours. Today you plan to ride for 3.5 hours. If you ride at the same rate as yesterday, how far will you ride? The 2 tables below show you 2 different ways you could arrange your information. First, you could set up miles and hours here, and today and yesterday here. In that case, you would simply record your information. So today, you're going to ride X miles, because you don't know how far you're going to go yet, and you're going to ride for 3.5 hours. Yesterday, you know that you rode 18 miles, and you spent 2.5 hours doing that. Okay. The other way you could set up this table is to put today and yesterday on your x-axis and miles and hours on your y-axis. Okay. So today you rode X, or you're going to ride X miles. You don't yet know how far it is. Yesterday you rode 18 miles. Today you're going to spend 3.5 hours riding. Yesterday you spent 2.5 hours riding. So your proportions can be written now in 2 different ways. Each will work. The proportion from your first chart, which I've marked in blue, would be written x over 3.5 giving today's distance in time, equal to yesterday's distance in time, 18 over 2.5. The other way of writing the information would put your miles in a proportion. So we have today's miles, x, over yesterday's miles, 18, compared to time. Today's time, 3.5 hours, over yesterday's time, 2.5 hours. The one thing you need to be sure of when writing your proportion is making sure you're using comparable ratios. Make sure you can actually compare what you're writing. So you can't write a proportion that compares miles to hours and hours to miles. Notice that in each we've compared miles per hour to miles per hour, or miles to miles and hours to hours. Okay? We've been really careful to keep our units the same. Now let's work out a problem together that uses this idea. Each day, an elephant eats 5 pounds of food for every 100 pounds that it weighs. How much does a 9,300 pound elephant eat per day? Okay, so we're going to set up a proportion to answer this question. First, we're going to write a proportion that uses the two ratios we know. We know that an elephant eats 5 pounds of food for every 100 pounds that it weighs, right? Now we can set up an equivalent ratio of x pounds food over 9,300 pounds of elephant. Okay? Now we simply solve using algebra. So we begin by simply multiplying both sides of our equation by 9,300 to isolate our variable. At this point, we can choose to cross-reduce to make our work just a little bit easier if we wish. That would reduce 100 to 1 and 9,300 to 93, giving us 93 times 5, which is 465, being equal to x. Okay, so our final answer is that a 9,300 pound elephant would eat about 465 pounds of food per day. This finishes up Chapter 6.2 for us. When I see you again, we will work on solving more proportions. See you then.